Let's look how to properly troubleshoot a system with the method used in Service 2022. You see here we have a house with 3 DirecTV receivers, one in the living room, one in the master, and one in another bedroom. The dish is located in the yard. For this example, let's say the customer is having an issue with the receiver in the master bedroom. Let's follow the proper steps to see what's going on. First thing we have to do, no matter what the work order type, is go to the dish and make sure it's properly tuned and dithered using install mode. Once we have it locked down, we want to know the power level. In this case, it's negative 26.9. Now we need to check a few more things while we're at the dish. Next, we need to go to Test and select SatTune. We will select the 101 satellite and transponder 2. We're looking for 2 things here. First is the offset. This should always be somewhere between negative 2 and positive 2. In this case, our value is between the 2, letting us know that our offset is good. If it was outside that range, example would be 2.2 or negative 3, we would need to replace the LNB. That is not necessary here since we have a good value. Next thing we want to do is note our signal to noise ratio, or SNR value. Here we have 14.1. Now we need to write down the power and SNR values. We're going to need those in a bit. The next step needed is to figure out our length of cable from the ODU to the splitter. We can do this in 3 different ways. The first would be if it's DirecTV approved cable, it will have footage markings on the cable itself. We can look at either end and determine the length of cable. Second would be to use a cable resistance test to figure out the length of cable. We'll talk more about that in a bit. The third would be to estimate the length, but it needs to be very close to the physical length of the cable itself. This can be done by stepping off the cable running through the yard, or maybe counting the pieces of siding and multiplying it by the siding's width. Now we need to write down our length of cable from the ODU to the splitter. Next, we need to figure out the length of cable from the splitter to the room that we're looking at. In this case, we're looking at the master bedroom. Once we calibrate the meter using the resistor as directed on the meter itself, we'll attach the 25 ohm resistor to the wall plate in the room we're wanting to know the length for. Now we need to go back to the splitter, attach the cable from that room to the AIM, and run the resistance test. 2 things will populate on the meter, a pass-fail and a resistance value. It's important to know that because it says pass doesn't mean the cable is good. The AIM has no way of telling how long the cable actually is. A failure, though, would indicate that the cable is bad. Now we need to use the cable length calculator available in SmarterU to help us. Using our phone, we navigate to Launchpad and click on SmarterU. On the left side, we click on the ellipsis menu. Now we click on Applications, and then on the cable length calculator. We need to enter the test results into the application. The app will let us know what the length of cable should be. Now we need to think about how the cable is running and see if what the calculator is saying seems to make sense. If yes, you can proceed. If no, then you need to figure out why the cable is showing longer than it appears. Examples would be copper-clad steel, splitter in the line, inline devices, coiled cable that's not needed somewhere, etc. Now that we have our length of cable from the splitter to the receiver, it's time to put it all together. We need to go back to SmarterU, go to Applications again. This time, we'll select the power loss calculator. It will look something like this. For this example, though, we're going to use the desktop version so you can see it a little bit better. It is important to note that both the power loss and cable length calculators are apps built by the training team that are linked into SmarterU. This means that you can bookmark both of those to your web browser or save them to your desktop for easy access. Now we want to enter all the information we've gathered. Our reading at the dish was negative 26.9, and the total length of cable was 149 feet, 34 from the ODU to the splitter, and 114 from the splitter to the IRD. We had a 4-way splitter in the system, so we'll also want to add that. There's nothing else in the line going to the master bedroom, so we will not input anything else. Please note you will only input items that are in line with the room that you are testing. Let's look at what we have. We should know that we can lose less than 2 volts DC and still have a properly running system. Anything over that in the LNB will not get proper voltage and the system will not work properly. So we have less than 2 volts lost, so we're good there. Next, we'll see our approximate power level. This is the power level we should see in the master bedroom. Now let's go to the master bedroom and check what our values are at the receiver. We want to make sure we're always using the same method of checking our values as we did originally to get them. In this case, we would use our install mode to look at our power. Looking at our power, we see that it's negative 48.2, which is very close to the calculator value, letting us know we are good here. Now, just like before, we're going to go to Test, go to SatTune, Satellite 101, Transponder 2, and look at the signal-to-noise level. Power is lost throughout the system and every component installed. Signal-to-noise should remain the same throughout the system. Here, our signal-to-noise is 14, which is very close to what we had at the ODU, letting us know that this room is within specs in all areas and shouldn't have any service issues. We have figured out what our values should be and have confirmed them using the meter in the applications. Now, let's say what we have found isn't what the calculator is saying we should have. Let's say we have a power issue. When we went to test the line going to the receiver, we find that the power is showing negative 56.2, and we should have negative 48.2. Let's look at what we should do and how to find the issue. First thing we want to do is go back to the splitter and see if the values we have coming into it are good, letting us know if it's an inside or an outside problem. Using the power calculator again, we will enter the values of everything coming into the splitter. The power remains the same at the dish at negative 26.9, but now we only need to count the cable length coming into the splitter, which was 34 feet. And because we are testing the line coming in the splitter, we will remove the splitter itself and change that to 0. We can see here our power coming into the splitter should be negative 29.96. Now let's grab our meter and see what we have. In this case, we have negative 30, which is very close, so we know we are good coming into the splitter. Now let's see what value we should have coming out of the splitter. For your information, this is the way to check to see if the splitter is good and not just guess and replace it. We will just add the splitter back into the application, and we see we should have negative 37.96. Again, we're going to grab our meter and test. And again, our values are in line with the app, letting us know that the issue is somewhere between the splitter and the IRD. After digging some, we find that there's another 4-way splitter installed that is not necessary, causing the power loss. Once we have removed the unnecessary splitter, it's time to go back to the room and retest. Now our power is negative 48.4, which is close to the calculator, letting us know that we have resolved the issue and the customer now has a solid system. Now let's go back and look at it if we had a noise issue instead of a power issue and how to troubleshoot and resolve. When we did our SatTune in the master bedroom, we found that our signal-to-noise ratio was only 11, when we were expecting close to 14.2. Let's go back to the splitter. Because signal-to-noise should not change throughout the system, this is a fairly easy issue to troubleshoot. Let's follow the same path as we did for power by checking the input to the splitter first. Looking at SatTune results at this location, we see that our SNR levels are good coming into the splitter. Now let's look at what they are coming out of the splitter. Here we have dropped and have a value of 11.2, which means that there could be an issue with the splitter or one of the lines connected to it. Looking a bit closer, we see that there's a line hooked up that shouldn't be. Remember, this customer only has 3 receivers. So now we want to unhook that line and see if our SNR changes. In this case, it did, letting us know that there's noise coming in from the line that was hooked up that didn't need to be. Now when we retest, we see that the SNR is up to 14.1, removing the customer's actual issue and providing a system that is in compliance. Look at that. We tackled that just like a tech and not a parts changer. Using this method will help you become more successful and improve not only your AIQ, but also your VOC and WTR numbers. If you're not using your meter and your calculation apps on every single job, you're just plain not doing your job correctly.